Hello everyone. Today, we're going to make sense of ion exchange chromatography graphs. These graphs might look complex at first, but understanding them is quite straightforward. We'll break down each part so you can read them easily and understand what your separation experiment is telling you. Let's start with the basics of any chromatography graph. First, look at the x-axis. This axis usually represents time, showing how long the experiment has run. Sometimes, it shows elution volume, which is the total amount of liquid that has passed through the column. This tells you when different components are coming out. Next, consider the y-axis. This axis measures the detector signal. Often, this is absorbance, which tells you how much light a substance is blocking, indicating its presence and quantity. It could also be conductivity, especially if you are monitoring salt concentration. So, the y-axis tells you how much of something is eluting at any given time. Now, let's talk about the main features you'll see: peaks. You will see one or more peaks on the graph. Each peak represents a different molecule or group of molecules that have been separated and are now eluting from the column. The height of a peak is important. A taller peak usually means there is a larger amount of that specific substance. Similarly, the area under the peak also indicates the quantity of the substance. The position of the peak on the x-axis, its retention time or elution volume, is crucial. This position helps you identify the substance. Different molecules will have different retention times because they interact differently with the column. The flat line before and after the peaks is called the baseline. This shows that no significant amount of your target molecules is eluting at that moment. Specifically for ion exchange chromatography, there's often an additional line on the graph. This line typically shows the salt gradient or the pH change that was applied during the separation. In ion exchange, molecules bind to the column based on their charge. To elute them, you usually increase the salt concentration or change the pH. The salt ions compete with your bound molecules, causing them to detach and elute. Weakly bound molecules will elute first, at lower salt concentrations. Strongly bound molecules will require higher salt concentrations to be released from the column. Therefore, peaks appearing later on the graph, at higher salt concentrations, indicate molecules that bound more tightly to the column. If you are using a cation exchange column, positively charged molecules bind, and the most positively charged ones elute last. If it's an anion exchange column, negatively charged molecules bind, and the most negatively charged ones elute last. So, what does the whole graph tell you? It tells you how many different components were in your sample, indicated by the number of distinct peaks. It tells you the relative amount of each component, shown by the peak heights or areas. It also gives you an idea of the purity of your separation. Well separated, sharp peaks mean a good, pure separation. Overlapping peaks suggest that your components are not fully separated. By looking at the salt gradient line, you can determine the specific conditions needed to elute each component. This information is vital for optimizing your purification process. We hope this simple explanation helps you read these graphs with confidence. Thank you for watching. If you found this helpful, please give this video a thumbs up, subscribe for more content, and consider sharing it with others who might benefit. Your support helps us create more educational videos like this one.